Do you currently use AI tools in
Yeah.
your math research?
Yeah, quite a bit. Yeah. So, I mean, maybe since, well, I don't know, let me give you the history of my experiments with these things. So I started playing around with AI, trying to get it to do math before ChatGPT 3 came out. So there was this, before it was available to the public, because OpenAI felt it might be too dangerous to release. There was this video game AI dungeon that used GPT-3 to just tell Dungeons and Dragons stories. So I bought it and I would try to get it to do math inside of the middle of a Dungeons and Dragons story. I think I probably started using the tools seriously to do math while trying around when O1 came out, which was in September 2024. And then maybe had my first successes around when O3 came out in summer of last year. Yeah, so right now the primary way I use the tools is for literature search. Sometimes they can like usefully prove a lemma or proposition that shows up in day-to-day research, and also it's very useful for like finding examples of things or counterexamples, like when you're going down some, you're trying to figure out if something could be true. So you look for a counterexample. It's very useful for that. And then also I've used them to code some scientific computing tools. So recently, for example, I used Codex to write some code to compute with parabolic Higgs bundles.
Do you keep track of the usage as you go along in research?
What do you mean by that? Sorry.
So if you've proved a lemma using AI, do you somehow keep track of
Oh, yeah, for
what
sure.
parts were proved by AI or what components?
Yeah, so far I've only had one paper come out so far in which a lemma was proven by AI. And we certainly noted that in the paper. I think that's kind of important to do right now, just at the level of, attribution. Like if you didn't contribute, if part of your work was contributed by someone else, you should credit them, and I don't see why the same shouldn't be true for the tools. So yeah, I do, and try to make sure my collaborators are okay with me using the tools and that kind of thing.
How do you personally feel about the growing role of AI in mathematics, and has it changed how you think about what it means to be a mathematician?
Yeah, I think from a scientific perspective, I'm really excited. Like the tools are rapidly growing in capability, and I expect that in the next few years they'll be able to do some really interesting mathematics. So I think that's like an unalloyed good. I think doing interesting mathematics is important, and we should want more of it. From the perspective of the profession, I'm a little bit worried. Like right now, already it's possible to kind of generate papers that would have been publishable a year ago in a fully automated way, and I think the structure of our institutions is not prepared for that. And I think we really need to think about how we're going to adapt in terms of like publishing, training, and so on. And I don't know. My sense is that we are not yet adapting, and it would be good to start seriously considering that. Yeah, I think it's changed it a little bit. So first of all, I think just thinking a lot about what skills are necessary to do math has been really useful, and that's something I've been doing is like trying to think about capability growth for AIs. Like, do they have the skills we have? An interesting thing I think I've observed, at least in my experience, is that despite growing capabilities, AI tools kind of have a very different skill set than I think strong mathematicians do. A lot of what we do, I think, because like an individual human doesn't know very much, is we reason about like, well, oh, could this be true? And then you kind of go to the literature and you try to understand, has someone thought about this before? And there's a lot of sort of invisible reasoning that we do just to sort of rediscover things in the literature. And I think that's actually sort of most of what we do. So there's a huge amount of creativity involved in being a human mathematician, but much of that creativity is focused on rediscovering what someone else knew. My experience is that the models are much less creative than humans right now, but because they know everything, they can substitute, or know sort of all the existing literature, they can sort of substitute that knowledge for some amount of creativity. There's a question as to like how much math research creativity is really fundamental. My feeling is it's like a pretty small proportion of math research, in the sense that ultimately a lot of mathematical work comes down to recombining things in literature, and the expenditure of creativity is in finding those things. But I think there is some portion of mathematical work which does require creativity in a way that isn't recombinatory. I'm very interested to find out what portion of the math literature that is, and also to what extent AI tools will be useful for that, which presumably will come in the next few years.
I have follow up to that. In the comments that you made about the disproof of the unit distance conjecture, you were talking about how AI went across silos, and again, in this case, in combinatorics and algebraic number theory, and I was wondering if you could talk about that.
Yeah, I mean, I think right. I think I commented that, like, maybe one reason this solution was missed is that mathematicians are relatively specialized in what we know, and I think that's actually one of my hopes for progress coming from AI is that AI isn't as siloed in that way. It has like very broad knowledge, and so hopefully it can help people connect different areas. I think a lot of human work also is about kind of connecting different areas, and like it's very common for me to like try to learn about a different field as part of a project. I think that's just part of being a mathematician. So it's exciting that AI can help with that. I think there's also something to be said about depth. Like a lot of my favorite work is about not just kind of taking puzzle pieces together and from different areas and slotting them in, but also just really trying to deeply understand a mathematical object. My experience so far has been that AI tools are not as useful for doing that, but hopefully they will be useful for that eventually.
So over the next 2 or 3 years, what role do you expect AI to play in mathematical research? And I understand it's very difficult to see into the future here, but what do you expect will be the role of AI?
Yeah, that's a good question. I mean, maybe let's just like briefly review the trajectory. So 2 years ago, AI's tools could not reliably add numbers. A year ago, they got a gold on the IMO, and now they're resolving, one major open question in combinatorial geometry, and I think, broadly helpful with math research. I think a lot of mathematicians are really using the tools now. So if you imagine that trajectory continuing, it's sort of hard to imagine, but I think that it's natural to expect that in a year, the tools will autonomously be proving much more interesting results and broadly useful in all areas of mathematics. I think there's a question about whether they will be equally useful for all mathematical activities. Right, so right now, there's been a huge amount of progress in like solving rigorously stated problems where the solution is relatively short, so like maybe 5 or 6 pages. I find it very plausible that they'll be able to, in a year, produce 30-page arguments or 40-page arguments that are correct. There's also been some question about how useful they are for theory building or sort of more exploratory aspects of mathematics. And my sense is that so far the progress has been a little bit slower, but there has been progress, so maybe we'll see a lot more in a year too. I would not be surprised if by let's say 2030, models available to the public could be prompted to produce, in a single prompt, a math paper of the high, like comparable to the best papers coming out this year.
Should mathematics education at the undergrad or graduate level change in response to current or future AI tools? And if so, how?
Yeah, so I think the answer is obviously yes. Maybe let me just say a word like how I think of the purpose of like mathematics in the academy. So like one part of it is to produce good science. And the other part is to produce human capital, so like people who can understand and work with that good science. So for the first part, we're training graduate students to produce good science. A lot of the things that a graduate student or a professional mathematician, where a task that required such a person can now be done by an AI. So I mean, like sort of, proving a lemma in a paper is something that previously would have required, a math PhD in most cases. Now it doesn't always require a math PhD. Now sometimes you can just use your, $20 a month ChatGPT subscription. And so my sense is, we should be focusing on doing the things where we can add the most value. What those are depends a lot on the shape of future capabilities, right? So if there's areas where the tools are weaker, of course we should be focusing on those. Like that's what why should we be focusing on the things where the tools are excellent? Okay, so there's a couple concerns there. So first of all, in order to learn math, you have to do exercises. Like we just don't have another good way of training people, I think. And right now, any exercise you could reasonably give an undergrad can be done by the models already. And I think soon any baby problem you could reasonably give, a first or second year graduate student will be able to be done by the models. We're relatively close to that. Okay, so that said, we still need students to do problems. I think our institutions need to adapt to in ways that kind of help students do that work, like even though there are easy ways out. And also, I mean, of course, we have to adapt assessment. Like at the undergraduate level, we can't give people take-home tests anymore. It's just not reasonable. Now, in my classes, at least all assessment I do via either in-class or oral exams. Yeah, so maybe it's worth saying, like, what happens if the models get better than us at all aspects of math research, or like all sort of outwardly measurable aspects of math research? I think that's possible. So what should we train students to do there? Well, okay, at least one purpose for me of math research is like human understanding of mathematics. And so at the beginning of this spiel, I said there are two purposes of math in the academy. One is the production of high quality science. The other is the production of human capital. And that second thing can't be automated. I think even in a world where AI tools are autonomously producing lots and lots of science of the highest quality, we'll still want to produce human capital to engage with it and understand it and use it. But I think even in a world where AI tools are producing high quality science or lots and lots of science at the highest quality, we'll still want to produce human capital to understand it and engage with it. That'll be a big part of how we have to adapt, is how to think about how to train people to engage with deep mathematics, and how to study it and learn to understand it, even if there are tools that are better than us at creating it.
What advice would you give to students or early career mathematicians thinking about a career in mathematics in light of the recent advances in AI?
Yeah, so the short answer is I don't know. I think the profession is going to have to change a lot. The precise shape of that change, I think, will depend a lot on the precise shape of AI capabilities. I think there is a world where AI becomes something like one very good mathematician with a certain point of view, and then we have a lot to offer because of our cognitive diversity and lots of different approaches, or maybe AI is not particularly good with certain types of mathematics or certain mathematical skills, and we'll end up focusing on those. In that world, I think the profession will change dramatically. Like, we'll definitely have to change, the journal system and how we evaluate people for jobs and that kind of thing. But it will survive in some form as like an activity where humans are doing interesting research and like producing lots of interesting mathematics. I think that definitely could happen. I think there's a chance that in the next few years, though, AI tools become able to produce high quality research much more cheaply than humans, and then the profession will dramatically change, and I think have to focus primarily on the production of human capital and human understanding. So those are two very different paths, and what being a mathematician looks like will be very different in those two worlds. So that means it's very hard to give certain advice. But we can think about like what is the same in those worlds, and at least what seems to me a constant is like, well, the math isn't changing. My primary motivation for doing math is like to try to understand what's true and why, and that's not an activity that disappears in either of these worlds. So if that's your motivation for doing math, maybe I would suggest like cultivating that and thinking more about what are the deep questions you want to understand, and how do you want to understand them, and would you be okay in a world where that understanding is more like reading a paper or interacting with the teacher than trying to discover it yourself. My personal view is that I am okay with that. I would be excited to learn the answers to all these like really hard questions that have been torturing me for years. I think that's kind of in some ways one of the healthier motivations for doing math. Like, you could be doing math because you would like your name etched in eternity as the prover of such and such a theorem. I think that like ego or whatever is part of doing math, but maybe it's not a part of doing math that will survive. And so I think it's, maybe my advice is to think about doing good math and learning interesting math as your primary motivation, and beyond that, I think any advice I have to give is sort of too sensitive to the details of future capabilities.
Is there a problem or a conjecture that if AI solved it, you would be devastated that it wasn't a human?
No, no. I think well, okay, maybe I've already made peace with this or something, but I think that there's no conjecture I care about where I would not be excited to see a solution from any provenance. Like if an alien were to come and hand me the solution, I would say that's awesome. I think we should worry about our livelihood and being able to eat and that kind of thing. But I think our goal as mathematicians should be to understand and produce high quality mathematics. And the provenance is not really relevant to that. Like if you view the outputs of our work as important, you should be excited to have more and better outputs.
What if the solution is some like formalized proof that is some like 5,000 pages of math that is going to take the rest of your life to understand what is happening in that?
So first of all, I mean, the tools are actually quite good now at taking a leading proof and deformalizing it, unformalizing it, and getting better. So I personally don't find that scenario too scary. Like I think we'll be able to make some sense of it. Okay, well, if you can imagine maybe a very long and complicated English language proof of a major result, and there's going to be a lot to learn, and well, that's really exciting, right? I mean, I don't know. When I started getting into math, I was an undergrad, and all I was doing was learning stuff people had already done, and yeah, that's still one of my favorite parts of doing math. It's very hard to read research papers, and my experience of reading a paper and trying to understand what's in it is not that different from my experience of doing research. You're really struggling with the objects, and the opportunity to do that more doesn't strike me as a negative.
I mean, what conjecture you want to be seen resolved the most that if AI could do, you would be really happy to see a solution of?
Yeah, so okay, I don't care who does it, right? It's not about the AI doing it. But yeah, I would be really excited. The sort of questions I've been thinking about recently are, my favorite question these days is the Grothendieck-Gatsby curvature conjecture. Of course, I would love to make more progress on that. But it would be great if AI solved it. My feeling is it's related to a lot of sort of basic questions in algebraic geometry, so some kind of non-abelian version of the Hodge conjecture. So solutions to that would, probably also give ideas for proving the Hodge conjecture, and so I would also be very excited about that. It's also related to the production of some kind of arithmetic Hodge theory, so a sort of gluing together p-adic Hodge theory at different primes, and there's been a lot of recent work on that, mostly coming out of Bonn, and I would also love to see more progress on that. None of this does it matter to me what the provenance of these results are. I just would like to understand more about these basic questions.
And has AI played any role in these sort of areas, like in Hodge theory? Has there been any movement?
Yeah, so I think basically no, right? Mostly what I'm discussing here is I think there's some questions where there are some serious theoretical obstructions to progress, and you need sort of new theoretical ideas, new theory building to move forward. So far, AI tools have been sort of minimally useful for that kind of thing. I expect them to improve in the future just because the rate of progress is so fast, but that's an expectation which is not grounded in much evidence beyond the trajectory. It's not, I have no reason to think that next year the AI tools will be useful for theory, except that they've been getting way better very fast. And broadly speaking, the tools have not been so useful in arithmetic or algebraic geometry as of June 2026. By the time this video is out, I expect them to be much more useful in this area. Certainly, I think these are questions where you need really big new ideas. It's not going to be that you won't have meaningful progress just by combining ideas in the literature, and so I think we'll need the tools to get much stronger before they have an impact on these questions. Watch the p-curvature conjecture get proved by AI before this video comes out.
Well, thank you very much for sitting down with me, and very excited to hear your talk at CT&T. So thanks for stopping by.
Yeah, my pleasure.